In this screencast, we're going to talk about how you can calculate the measures of angles and arcs when they're formed by chords, secants, and tangents. So here's our first theorem. It says that the measure of an angle formed by two chords that intersect inside a circle is equal to half the sum of the measures of the intercepted arcs. Okay, so what does that mean? Well, if I want to know the measure of this angle right here, that's formed by two chords inside the circle, then this theorem says the measure of angle A, E, B is half the sum of the intercepted arcs. That's this arc right here and that arc right there, the arcs that are intercepted by the two chords that form angle AEB. So that's half the measure of arc AB plus arc CD. Well, what happens when we have an angle formed by secants, tangents, or a combination? All right, here's what it says. It says that the measure of an angle formed by two secants, two tangents, or a secant and a tangent drawn from a point outside the circle is equal to half the difference of the measures of the intercepted arcs. So, if I want to find the measure of this angle E, then the measure of angle E is 1/2 the difference of the intercepted arcs. So it's going to be this arc minus that arc. So it's half of the measure of arc AB minus the measure of arc CD. Same thing works for two tangents. If I want to figure out the measure of this angle E out here, it's going to be half the difference of this arc here minus that arc there. So the measure of angle E is 1/2 the difference of arc A, CB minus measure of arc AB. And then this is just using a tangent and a secant in combination. So the same rule applies. I'm going to do the measure of this arc minus the measure of that arc and multiply by 1/2. So the measure of angle E is 1/2 the measure of arc AB minus the measure of arc BC. So here's the rule. If the angle is formed by chords, so it's inside the circle, it's half the sum. If the angle is formed by secants or tangents outside the circle, it's half the difference. So let's apply what we just learned to some examples. On this picture, we're supposed to find the measure of arc WT. That's this arc right here. Well, you'll notice that it is intercepted by this secant and this tangent, so we're going to do half the difference. Okay. So let's call the thing we're looking for X, and here's the other intercepted arc, and it's 100, and here's the angle. So according to the theorem we just learned, the measure of 30 degrees is equal to half of 100 minus X. I multiply both sides by 2 to get rid of that 1/2. And from that, I'm going to get negative 40 equals negative X. So 40 equals X. All right, we have the measure of arc WT. That's 40 degrees. So I'll erase that now and fill in what we know. Okay, how about the measure of angle TVS? Okay, here's angle TVS right here. It's formed by this chord here and this chord here, which intercept, let's see, it's going to be, I'll do this in red, it's going to be this arc here and this arc right here. Okay, now since that's an inside angle, we're going to do half the sum So that's half of 100 plus 110, which is half of 210, which is 105. Okay, how about the measure of angle RVS? Okay, that's this angle right here. It is going to be the supplement to 105, so it's going to be 75 degrees. Okay, so what does that make the measure of arc RS, which is this arc right here? Okay, so we're going to say that 75 is half the sum of arc RS plus 40, because those are the two intercepted arcs. Okay, multiply both sides by 2 to get rid of the 1/2. 150 equals the measure of arc RS plus 40. Subtract 40. 110 is a measure of arc RS. Now, another way I could have figured that out is notice that I've got, if I add up all the arcs going around the circle, I've got 110 plus 40 is 150, plus another 100 is 250, and so if I just subtract 250 from 360, I get 110. So there's more than one way to do these. So let's do some quick examples here. Here's an angle formed by two secants. It's outside the circle, so it's going to be half the difference of the intercepted arcs. So here's one intercepted arc, and here's another. So set up the equation. 10 degrees is equal to half the measure of arc AB, that's what we're looking for, minus 20. Multiply by 2, so 20 equals the measure of arc AB, minus 20, add 20, and we get that the measure of arc AB is 40. Here we've got an angle formed by two chords. It's inside the circle, so we're going to do half the sum. So 85 degrees is half of measure arc RS plus 105. Multiply by 2, and we get 170 equals the measure of arc RS plus 105. Subtract 105, 65 equals the measure of arc RS. And our last example, now we have an angle formed by two tangents. It's outside the circle, so we're going to do half the difference of the intercepted arcs. Okay, so if this arc here is 110, then this arc here is going to be 360 minus 110, which is 250. So the measure of angle S is half the difference of those intercepted arcs, which is half of 140, which is 70. Okay, here's a little shortcut. Anytime you have an angle formed by two tangents to a circle, the angle is always going to be the supplement of that arc that's closest to it. All right?